Hello and welcome to today's podcast on the Hyperbola by Robbie, Burke, Gearoid, Larkin, Damien, Egan and Johnny Kelly. So first of all, what is a hyperbola? It is a section in the planes when a plane cuts both naps of a cone on one side of the axis. So as we can see here, when a plane cuts on one side of the axis of two cones, we are left with this curved shape called a hyperbola. The learning intentions for today's class and podcast is students will identify and relate examples of hyperbolas in nature and design. Students will construct a hyperbola using the compass method, and students will gain confidence in their drafting using new techniques. So, the first activity we're going to do in the class today is a think, pair, share. So how this works is we think about the answer to the question in your mind without talking. Next, we pair up with your partner and take turns sharing your thoughts, and then you listen to your partner's thoughts. And finally, you share the thoughts with the whole class. So before we begin our activity, we are going to look at the hyperbola model we have created in SolidWorks. So here we see two cones joined. You can see the plane here cutting through our two cones, and we can see the curved shape that is created, which is known as the hyperbola. So now, after the student seeing the model of the hyperbola and the shape it makes, the curve it makes, we go back to our think, pair, share, and we allow the students to think about different examples in everyday life of hyperbolas. After this activity has been completed, the students will share their answers with the teacher and he will write them up on the board. Next, the teacher will share his real-life examples of hyperbolas that he has found. So firstly, we see cooling towers of a nuclear plant. We see a Pringle, curve on a Pringle, the curve on the shadow of a lampshade, and finally the rims of a hurling ball all make the hyperbola shape. So next we're going to look at eccentricity. So eccentricity is the ratio from any point on the curve between the directrix and the focal point is called eccentricity. So this might be a bit strange for students, so an easier way to explain it we're going to use is mathsisfun.com, which will help explain it a little bit better. So eccentricity is how much a conic section, such as a circle, an ellipse, a parabola or a hyperbola, varies in being circular. A circle has an eccentricity of 0, so the eccentricity shows us how uncircular the curve is. The bigger the eccentricities are, less curved. So at eccentricity equals 0, we get a circle. Eccentricity less than 1, we get an ellipse. Eccentricity equals to 1, we get a parabola. And eccentricity greater than 1, we get a hyperbola, which will we see what we are doing today. So here we see the little animation of this. So if it's equal to 1, we get our parabola. If it's less than 1, we get our ellipse. And the one we're looking for today, greater than 1, we see our hyperbola, as seen here. So next, we are going to look at solving a question using the compass method to find a hyperbola. So firstly, we draw our XY line. So next, how do we locate the vertices of both our hyperbolas? So this is a question we're going to pose to the class. And the answer is we draw a circle of given radius on the XY line, as shown here, which will give us our vertex 1 and our vertex 2. Next, focal points are located an equal distance from the vertices. We will be told the distance between one vertex and one focal point, and it's the exact same on the other side. So they're at equal distance from both vertices. So how are we going to find the points on the hyperbola? So this is another question we're going to ask to the students. How do they think we're going to find it? So what we do is we mark out points A, B, C and D at equal distance from F2, as shown here. So to find our curve, points on our curve, this is the method we use. We measure distance from V1 to A, and we swing an arc from our focal point 1 and focal point 2, which gives these two curves, shown here in the green. Next, we mark the distance from V2 to A, and again we swing a curve from F1 and F2, as shown here in the blue curves. The next question we're going to pose to the students is, where these two curves cross will give us what? And the answer is, these are points on our hyperbola. So now we have points on our hyperbola. The next question we're going to pose to the students is, how do we find more points on for our hyperbola? And the answer is, we repeat the steps which we did for A with B, C and D. So a little recap is, we measure distance from V1 to B, and we swing a curve from F1 and F2. We measure the distance from V2 to B, and we swing a curve from F1 and F2, and we repeat the same process for C and D, which will give us all these intersection points. So in the next question we're going to pose to the students is, what are all these points? And the answer is, these are all points on the hyperbola, and what we create when we join all these points will create our hyperbola. So now we have our two hyperbolas created. The next thing is, we want to create a tangent to one of these hyperbolas. So how do we do this? First of all, we're going to ask the students, what is a tangent? And a tangent is a line that hits a curve at one point only. So we are going to get in a question, we will be given point P on the curve. So how do we find a tangent to this? So the method is, we join F1 to P and F2 to P. Next thing we do is we bisect the angle F1P F2. Bisecting an angle is a skill the students will have learned in first year of school, and they should be well able to bisect an angle by now. After bisecting the angle, we join P back to where the angle was bisected, and we find our tangent to the hyperbola, as seen here. So, students might find this very difficult to follow, so we have created a YouTube video on step-by-step on how to create a hyperbola with a tangent using the compass method. And finally, we have our QR code, which is an augmented reality, so the students can download the eDrawing app and scan the code, and they can see the model in real life. They can spin it around and do whatever they want with the model to help them visualize it for their questions. Thanks for listening.